We've already been introduced to the chi-squared statistic in other videos. Now we're going to use it for a test for homogeneity. And homogeneity in everyday language, this means how similar things are. And that's what we're essentially going to test here. We're going to look at two different groups and see whether the distributions of those groups for a certain variable are similar or not. And so the question I'm going to think about, or we're going to think about together in this video is, let's say we were thinking about left-handed versus right-handed people, and we're wondering, do they have the same preferences for subject domains? Are they equally inclined to science, technology, engineering, math, humanities, or neither? And so we can set up our null and alternative hypotheses. Our null hypothesis is that there is no difference in the distribution between left-handed and right-handed people in terms of their preference for subject domains. So no difference in subject preference for left and right, for left and right-handed folks. And then the alternative hypothesis, well, no, there is a difference. So there is a difference. So how would we go about testing this? Well, we've done hypothesis testing many times in many videos already. But here we are going to sample from two different groups. So let's say that this is the population of right-handed folks, and this is the population of left-handed folks. Let's say from that sample of right-handed folks, I take a sample of 60, and then I do the same thing for the left-handed folks. And these don't even have to be the same sample sizes. So the left-handed folks, let's say I sample 40 folks, and here is the data that I actually collect. So for those 60 right-handed folks, 30 of them preferred the STEM subjects, science, technology, engineering, math. 15 preferred humanities, and 15 were indifferent. They liked them equally. And then for the 40 left-handed folks, I got 10 preferring STEM, 25 preferring humanities, and 5 viewed them equally. And then you see the total number of right-handed folks, total number of left-handed folks, and then you have the total number from both groups that preferred STEM, total number from both groups that preferred humanities, total number from both groups that had no preference. So let's just start thinking about what the expected data would be if we are assuming that the null hypothesis is true, that there's no difference in preference between right and left-handed folks. This is the right-handed column. This is the left-handed column. Well, assuming that the null hypothesis is true, that there's no difference between right and left-handed people in terms of their preference, our best estimate of what the distribution of preference would be in the population generally would come from this total column. Since we're assuming no difference, we would assume that in either group, 40 out of every 100 would prefer STEM, or 40%. 40% would prefer humanities, and 20% would have no preference. And so our expected would be that 40% of the 60 right-handed folks would prefer STEM. So what's 40% of 60? 0.4 times 60 is 24. And similarly, we would expect 40% preferring humanities. 40% times 60 is 24 again. And then we would expect 20% of the right-handed group to have no preference. So 20% of 60 is 12. And these, once again, they add up to 60. And then for the left-handed folks, we would go through the same process. We would expect that 40% of them prefer STEM. 40% of 40, that is 16. On the humanities, again, 40% of 40 is 16. And equal 20% of 40 is 8. And then all of these add up to 40. And now we're ready to calculate our chi-squared statistic. We would get our chi-squared statistic is going to be equal to the difference between what we got and the expected squared. So 30 minus 24 squared divided by the expected divided by 24. And we'll do it for all 6 of these data points. So then I will go to the next one. So then this is going to be, so plus, and if I look at this and this here, I'm going to have 10 minus 16 squared over expected 16. And then I'm going to have, I'll look at that data point and that expected, and I would get 15 minus 24 squared over expected over 24. I'm running out of colors. And then we would look at those two numbers, and we would say plus 25 minus 16 squared divided by expected. And then we would look at these two, plus 15 minus 12 squared over expected over 12. And then last but not least, let me find a color I haven't used. We would look at that, and we would say plus 5 minus 8 squared over expected over 8. And I'm not going to calculate it here, but we're going to get some number for our chi-square statistic. Now, once you get that value for the chi-square statistic, you then can look it up in a table to figure out what's the probability of getting a chi-square statistic that extreme or more. Now, the next question you might say is, well, to use a table, I need to know the degrees of freedom. So how many degrees of freedom do I have here? Well, if I know the STEM and humanities preference for right-handed folks, and I know the total number of people I sampled, I know what I'm going to get for equal. Likewise, if I know these two data points for the left-handed folks, and I know that I sampled 40 folks, I know I can figure out this equal this 5 right over here. So we have 4 degrees of freedom. And so we're going to use this data and this data to then come up with a p-value, which is the probability of getting a result at least this extreme. And then if this p-value is below our significance level that we would have set ahead of time, it might have been 5% or 10%, then we would reject our null hypothesis, which would suggest the alternative.